Twin Primes Extra. My motto: plain honesty, simple truth, easy understanding. The joy of finding things out for yourself. This upload contains more actual facts regarding twin primes, which I feel enhances last month's upload and will hopefully be of interest to many. Scarcer than the primes. Scarcer than twin primes. Scarcer than pig shit. I give you the twin primes starting with 11 and 13 and 17 and 19. The next two slides give the number of twin primes in 30 consecutive blocks of 90 million integers, starting at 1 and finishing at 2.7 billion, and gives the first prime in the first twin prime pair of any block and the first prime in the last twin prime pair of the block. We find there are 62,643 twin prime pairs, or 0.00232% in the first 2.7 billion integers. Scarce they might be, but still present in sufficient quantity to show that they play a significant and meaningful part in the formation of both the primes and composites from one another to form the number line that is the infinity of integers that we understand. The curve and equation, next slide, resulting from a plot of number of twin primes per block against number of integers, has symmetry and simplicity beyond belief. It seems pretty good in practice, but that's not to say that the results of repeated trolling way beyond what is humanly possible would maintain the trend. From the equation for the graph, the actual and estimated twin primes per block of 90 million numbers can be obtained and compared. They show good correlation for what is in an inherently unpredictable, variable mathematical entity. Welcome to Bateman's analytical continuation for infinitely decreasing power and exponential functions. 1. Taking the equation for the actual number of twin prime pairs, we derive the first 143 values and separate into 13 lots of 11 and sum each lot to find the total of twin prime pairs per lot. 2. We take the 90 million integer lot from graph 1 and multiply 11 to give 990 million for the size of the new integer lots. Starting with x equals 990 million, the value for the next lot is given by x equals x plus 990 million. 3. The two columns of numbers obtained are shown in the table and used to plot graph 2, shown on the next slide, and obtain the new power curve equation. The process of obtaining a new graph and predicting equation I have designated consolidation, so this graph represents the first consolidation step. 4. Taking the equation for the first consolidation of twin prime pairs, we derive the first 150 values and separate into lots of 10 and sum each lot to total the twin prime pairs per 9,900 million lots. 5. The two columns of numbers obtained are shown in the table and used to plot graph 3, shown on the next slide, and to obtain the new power curve equation. This is consolidation step 2. 6. We proceed from step 2 to step 3, and step 3 to step 4, and so on and so forth ad infinitum. The number of consecutive consolidation lots and the amount of consolidation is arbitrary, and I chose to consolidate lots of 11 and 10 per lot for 13 and 15 lots. It can be seen after just 2 consolidations that the process can be carried out indefinitely, and that therefore there must be an infinite number of twin primes, and consequently infinitely many twin primes. So the twin prime conjecture is proven, QED. Had the analytical continuation for infinitely decreasing power and exponential functions been proffered by a grade A plus or grade Z minus mathematician, then it would have been hailed as a great mathematical achievement, warranting a grade rise to grade A++, and the award of a Fields Medal combined with immortality in the annals of mathematical folklore. As things stand, it will just be dismissed as crank mathematics, and then they will continue on their merry way with their nonsense of trying to bring down the size of gap that can exist between an infinite number of prime pairs. That's all, folks. Hope you enjoyed the maths, and thank you for watching.